Hello, and welcome to Chapter 13 Homework. Again, maybe lucky for some, maybe not, but this deals all with linear regression and correlation. So again, our introduction to regression, and probably going to be using a lot of Excel, because it's probably the best way of actually solving for regression. So, starting off, we have Pennsylvania Refining Company is studying the relationship between the pump price of gasoline and the number of gallons sold. For a sample of 16 stations last Tuesday, the correlation was 0.55. The company would like to test the hypothesis that the correlation between price and number of gallons sold is positive. Right? And then they say state the decision rule for 0.01 significant level. First off, we know this is going to be a one-tail. How do I know this is a one-tail t-test? Well, it's right here. They only want to know if it's positive. Okay, so that tells me that they're not worried about the negative. Thus, why we only have one t when we reject the null. If it was a two-tail, we would have a range. Basically, both the ends of the t-tails, or the end of the graph on the curve. Sorry about that. So, we need to find what our critical value is. So, in order to do so, we're going to take our book, get it, and we'll go and look for significant level test, one tail, and we're going to find our significant level. This was 0.01. Here it is. Okay, now degrees of freedom. Since we're dealing with two items, we're going to take the number of stations minus 2. For me, that's 16 minus 2, which is 14. Make sure we're in the right column. So I'm sitting at 2.624. And again, make sure you double check everything just in case you might have input the wrong number or did some transportation. Just be careful. Next, it says compute the value of the test statistic. Value of the test statistic is blah blah blah. Alright. So what we're going to end up putting in to our calculator is going to be the fun formula. This one. Zoom in. So it's this one right here. T-test for correlation coefficient, where R is actually our correlation. And we've already calculated or given that as 0.55. So there's two ways to do this. We can either do it on Excel, which makes putting in the numbers easy, or you can use your calculator. Either way is fine. I'm going to go ahead and put it in Excel. Reason why is, again, I kind of want to build the formulas out so I can already have them ready for me in case I get a harder problem. So I'm going to print it out right here. So we have our correlation and basically sample size. So I'll just put size. Reason why I'm doing this again is to build the formula into Excel if you haven't done so already. This way, again, you have it already pretty much pre-programmed. That's what we're doing. We're basically using the software to program our formulas. So we know to find t, or just looking for the test of correlation coefficient, it is going to be the correlation multiply the square root. So remember to get that function of the size minus 2 okay. I'm going to go ahead and put an extra parentheses around this because we are dividing and we don't want the order of operations to get messed up. So it's going to be divided by the square root of 1 minus power. Remember, you got to put the power formula because we're going to be squaring. So our correlation, comma, 2. And one more. There we go. Because they have multiple parentheses there. Alright. So there's our formula. Notice that it's going to say hashtag num because we have no numbers in yet. It's missing numbers. So we're going to go ahead and put our information in. 0.55 and we have 16. And there's our calculation. Whoa. So our calculation is 2.464. Because it says round to 3 decimal places. So we're going to check. Boom. Again, using the software to help us out. Now remember, we're going to reject if it's greater than 2.624. It is very close for me, but is less. So I cannot reject. So do not reject the null. You may have something different. Remember, if this is greater than this number up here, you would reject. So, we cannot conclude that the correlation in the population is should be greater than or than 0. Yeah, because again, since it's the alternative that we basically rejected, basically we cannot prove that it's positive. So we cannot prove that the correlation of the population is greater than 0. Now, yours may be a little bit different, because again, this is algorithmic. But that's how we would solve for problem 1. Next, we're going to have a little fun. So, the following sample observations were randomly selected. Round your immediate calculations and final answers to 2 decimal places. It actually gives us the Excel data. So we're going to pop this up. Alright, so here's our data. You know how I'm going to solve this one real quick? Probably going to do a data analysis. Make sure we're on regression. Hit OK. Make sure you only highlight the numbers that are needed, because sometimes it does have a little I'm going to click output range. I'm going to tell it to do it right here. Reason why is that I don't have to switch back and forth from worksheets. Okay. Then we can hit OK. And there's our regression. Now, for this, we need to do the regression equation, which is the y-intercept which it already gave me as 1, and basically our slope. So, and it says 2 decimal places. So 1 plus 0.88. We'll go ahead and check. There we go. So again, I didn't have to go through all the formulas for actually computing the intercept or the x value when it gives me the data. Okay, that's the nice part. Again, using the software to help us out. Turn the question, and now we can solve basically when x is a number. So for us, we can pop up our calculator real quick. Take 0.88 times 4 for me is 3.52, and then add 1. 4.52. Check. Everything's correct. We're good to go. That made it a lot easier and less complications of instructing of how to actually do it. Alright. Here we go again. Might as well show y'all one more time. So, the owner of we're going to go with that, Ford Volvo, wants to study the relationship between the age of the car and its selling price. Okay, those are our 2 items. Listed below is the random sample of 12 used cars sold at the dealership during the last year. Okay. See, it should have downloaded. Enable editing. Alright, so here's our information. Remember, we will have our dependent and independent. And since we're going to do data analysis. Now, if your Excel does not have the data analysis, please look back at the lecture video, because that's where I showed how to put this into Excel. Alright, so again, our Y range is always dependent, so it's going to be the price, because again, the price is more dependent on age. The older the vehicle is, the price will probably fall. Okay. Okay. Alright, so here is our regression. Now, notice that it already has, should indicate by a minus sign. So there's probably going to be a negative. Always will be. Again, using my regression, here is my A, the 13.6. Let's see, 3 decimal places. Okay. So, 13.60649. So it's basically 13.606. And my B is my slope. So, that is a negative 0.514. Okay, let's check. Make sure our regression worked. It did. Yay! Okay, estimate the selling price of a 13-year-old car. Okay, so, again, I can take my calculator. We have basically a negative 0.514. So negative times 13, and then add it to 13.606. We're looking at 6.924. Let's see. Yep, round 3 decimal places. 6.924. Make sure I put it in correct before I double check. And there's our answer. Alright. So, interpret the regression equation in dollars. Round your answer to the nearest dollar amount. So for each additional year, the card's going to decrease how much in value? Well, negative 0.514. Oh. Turn. Maybe. So it's probably because it's in thousands. So, negative 514. Huh. Because that is a slope, and it does go down by 0.514. So we could do this real quick. So 1 times negative. Okay. CC. So basically it should go down by so each additional year. So if I did 1 times negative so the card should decrease by 514. That is the slope. So it is every time we add another year, should be that times that slope. So there you go. Make sure you don't put negative. That was my bad. I put the exact slope. All you had to do was basically put in it as a positive. Okay. Learn how they're going. So, 514. Yeah, it's just your slope times 1,000 to get back in thousands. Alright. Giving the following ANOVA table. Determine the coefficient of determination. Okay. So we'll actually have to do some formulas here. So let's go find our formula. 13. We're going to look for that coefficient of determination. Okay, here is our coefficient of determination. Right here. Basically R squared. Now, typically if we have the data, we can easily find this. But we don't. We only have the ANOVA table. So, we can take it two different ways. We can take SSR, divide by SS total, or 1 minus SSE, divide by SS total. Since we do already have the regression, we could go ahead and just take the numbers. Calculate. So, 1800 divided by, oh, I still have some reminiscences from a formula. 1800 divided by 27. So we got 0.6 repeated. So 2 decimal places, 0.67. There we go. Alright, assuming a direct relationship between the variables, what is the correlation coefficient? Okay. So, correlation coefficient is just R. It's just R. So if this is R squared, guess what I'm going to do? I'm going to take 0.67 and give it the square root. So this is 0.8. How many? 2 decimal places. I always got to remember 2 decimal places. 818, so it's 0.82. Okay. Be careful of that. Remember, correlation coefficient is just R. The coefficient of determination is R squared. So define correlation coefficient is the square root of this. Third question. Determine the standard error of estimate. So, standard error of estimate Alright. I just had to play with it. Let's go find the formula. So, the standard error of estimate is going to be a fun one to calculate. But, let's see. So it equals the sum of y minus y hat squared divided by n minus 2 square root. See, how do we figure this out when we don't have the number? I'm sure that there's Okay. Okay. So, formula is square root of the sum of y minus y hat divided by squared divided by n minus 2. In the ANOVA chart, this is already here. This is going to be our SSE, basically divided by our degrees of freedom, and we square root it. So, calculator, 900 divided by 10, and square root. So it is 9.49. Okay, check. There we go. So that solves question 4. That was a little bugaboo. Because it really is interpreting the ANOVA and figuring out the correlation. But then again, here's the MSE. So basically, it's the square root of the MSE. Okay, next. 5. I'm about to say 15 for some reason. Not even 15 questions. Alright, on the first statistic exam, the coefficient of determination between the hours studied and the grade earned was 78%. The standard error of estimate was 11. There were 25 students in the class. Develop an ANOVA table for the regression analysis of hours studied as a predictor of the grade earned by the first statistic exam. Okay. So, the standard error of estimate was 11. We know that's 11. Again, check. Standard, oh, okay. Standard error of estimate, I did not do the formula. Alright. I just went with the SSE, sorry. Alright, so this is going to take a little bit. First off, we got the 25 students. We know this is going to be 23. Again. And this, I believe, will be 24. Yeah, because the total is always like n minus 1 when it comes to degrees of freedom overall. So that will leave my regression with 1. Again, notice how I'm checking my work just to make sure that I'm on the same path. Okay, so we know what the error is. Degrees of freedom is 23. We do not know what this one is, or MS. Okay, but we do have some numbers to work with. And we're going to have to do some fancy algebra, it looks like. So, in our formula, which is this formula right here, we do know the standard error of estimate is 11. We also know this number now, 23. Okay, it's always n minus 2, so it is 23 for the degrees of freedom. What we don't know is this number, which will color size to our SS. So, how do we figure out this number? Well, here we go. Algebra. 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 So, 11 will have to first be squared. Why squared? Because we have a square root on one side that we have to remove. In order to remove a square root, you must square it. So that's 121. We're going to divide that now. Well, we're not going to divide. We'll multiply it by 23. So we're looking at 2,783. See if I did my algebra right. And we did! Yay! So it's 2,783. And find our MS. That will be, calculator, 2,783 divided by 23, or 121, just to make sure. Okay, so check, and there we go. Okay, so that's solved 1. Now, we have to figure out the coefficient determination to create the SS total. So, we have a few things that we can do. We can know that the correlation coefficient, or coefficient of determination, since it's 78 degrees, that is basically r squared. Now, that would be 1 minus SSE divided by SS total. Okay. So, again, using our calculator and our math. So basically, we're using this formula right here because we don't know what SSR is. So SSE. So first off, we have 0.7. Oh, sorry guys, 0.78. We're going to subtract the 1 because it's a positive 1 on our side. Don't worry, we're probably going to fix that in a little bit. Now, we do not know what the SS total is, but we do know what SSE. So, I wonder if I can draw this to show you what's going on. Or, let me use my Excel. Alright, new workout. So we know the formula is 1 minus SSE divided by SS total. So this is what we're using. We know for me, 78% is our coefficient of determination. So next, we have to basically use the algebra to solve for SS total. So first job is to take 0.78 minus 1. We have to get that 1 over. So that's still going to equal to our SSE, which for me is 2,783 divided by X. We're going to put X because we don't know what SS total is. Alright, so we know this now. Oh, don't forget, this is also a negative because it's minus. Alright, it's going to do that. You don't want no equal. Okay, it's going to do, just have a little fun there. Let's see, we're going to go home. See if I could just make it text. And delete. There we go. Just so that y'all can see what's going on. Alright, so we know 0.78 minus 1 is negative 0.22. Here, we now can move our next step, because this is the same thing. Okay, so we know it still equals to this amount. Or here, we have X on the bottom. We cannot have X on the bottom, so we're going to multiply by X on each side. So 0.22 X now. Oop. They're just having their fun. Make this both text so it doesn't do that. Negative 0.22 X because we multiplied, leaving us with negative 2783 over here. Now, because x has moved over, we have to divide. So x will stay here. Then I'm going to make sure this is text so y'all can see. Well, actually, we don't have to, but I'm going to show you the text. So we have negative 2783 now divided by 0.22, which is negative as well. Okay, now we just go ahead and solve. So negative 2783 divided by negative 0.22. So we're looking at 12,650 is our total. Again, we'll check, make sure we did our math, and there it is. So, a little bit of algebra here. So, that does end up happening. We do have to figure out as we go. So, this makes it a little bit easier now. Now we got the too complicated. 12,650 minus 2783, 9,867. And since for us, degrees of freedom is 1, it should actually be the same number. And there we go. Woo! 5 actually gave us a little run for our money with algebra. 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 So, again, if you want to see how I did the standard error, we basically had here on Excel. So I'm going to just run this as text real quick to just show you how the formula came to be. So text, up here too. Alright, so for the standard error of estimate, because this is probably a little bit better way of showing, is again our S subscript rhyme times X. Fortunately, I can't do subscript right now, but square root of sum y minus y hat this was actually, if it was in calculator form, in Excel form, this would have been power sum of y minus y hat squared divided by n minus 2. Alright. So basically it's the square root of y minus y hat squared divided by n minus 2, because that is basically the only way that we would be able to put it into Excel, working with the formula. For ours, we know this answer. This was 11. It was right there, standard error estimate. We know it's going to be the square root of basically our SSE divided by 23. Again, 25 students. So from there, since we're done with the square root, basically I have to square, so power 11, 2, and we would have squared the other side, which will leave us with only SSE divided by 23. From there, we found out that this is 121, which is actually our MS. SSE divided by 23. Notice that 23 now is on the bottom. So we would have to multiply both sides. 121 times 23, which leaves us with our SSE. Again, equals. Well, I still have it as text. And there's our 2,783. That matches to our SSE. So again, hopefully that helps on when you try and do this problem. Question 6. So here we have confidence intervals. Yay! So, here in itself, again, we're going to have to determine the formula. So for us, we really do need to figure out what the formula is and all those. So we can make it pretty easy by first making our making our Excel. So let's go ahead and do that. I'm just going to do a blank sheet here. Let's put in our X's. 4, 5, 2, 6, 10. And our Y, 6, 3, 1, 7, 7. Okay. Let's go ahead and put in our data. Data analysis, regression. Right range is there. X range is there. Now notice that it does have confidence level. This should match what your confidence interval is. That range looks a little odd. There we go. Yeah, okay, so that's where my error was. That was weird. So, 90. Hit OK. Because again, I have to make sure my confidence level is correct. Now, notice that done 95%. Then we got also 90. Question is this the same one? So it doesn't really give us our confidence interval. Bonk, bonk, bonk. But it does give us some information that we do need to figure out the confidence interval. First off, we do need to find our basically y hat in our confidence interval formula. So let's go ahead and do that one. So when x equals 4, again, calculator, we have well, actually we could be a lot more accurate. Let's just use the formula here. So equals the intercept plus 4 times our x variable or slope. Sorry. So we're looking at 3.869. Let me zoom in. There we go. 3.86932, or if we're rounding, which is probably going to be right about 3 decimal places. So there we go. 3.869 is our right hat. Next, our formula. Oh, wrong PowerPoint. Here it is. So these are our formulas. Remember, the mean is this right here. And then the prediction interval, which I believe is the second one, is going to be this one right here. So we're going to have to do some math. Everybody's like going, oh no, no more math. Remember, the only difference between these two formulas is the one that's added right here. Okay. So you know how I like to play these? Since we do have our x and y up there, first off, we need to figure out our mean. So mean of x is right here. So again, we're just going to do equal sum of these numbers. And it's going to be divided by 2. Oh, not 2. Why am I thinking 2? 1, 2, 3, 4, 5. Yeah, 5 numbers. So that is our mean, 5.4. We'll go ahead and insert a few because we need to have x minus x bar, and of course that's going to be squared. And then we're going to have it divided by the sum of x minus x bar squared. So, you know this is going to equal power of this minus x bar, which is 5.4, comma 2. Okay, then we figure out the sum. So that's 35.2. Okay, so time to start putting in the formula. We do need to know our t critical value. Now don't get fooled right here. This t-stat here is actually the calculated. So, critical value, we know our degrees of freedom is in minus 2. That happens to be 3. So let's go find that using our handy dandy book. Remember, we're at 90% confidence level. 3 is 2.353. Okay, so let's start piecing a little bit of our formula. So we know the confidence interval level is our t statistic multiplied by our standard error. Right there. See, it's already done for us. Multiply by the square root of 1 divided by our number. So, a number of observations right there. So that's also given to us. Plus our x minus x bar squared. Now our x is 4. So we already have this, but because we're just going to end up putting it in, we can do 4 minus, or if we're actually making the formula, we could actually put in our numbers, but to be safe, we'll just go and do that. Make sure we put it as power. Divided by our sum. Alright, fun formula. So, we're going to hit enter. Tell it to go yes. And it looks like we're at 2.4992. Now remember, we have our y hat. That was equaling to 3.869. So our interval is basically equal to this minus this. So that's the negative. This is, and this is the positive. So this will equal to this plus this. Alright, so let's double check, make sure we got them in correctly. So 1.369, 6.369. There we go. Nice. Alright, so the prediction one, so this is the, I'm going to call it CIM for confidence interval mean, and this is confidence interval, we'll put P for prediction. It's going to match the same thing, so we're going to tell it to copy. And right here, we're going to paste it, but there's one slight difference in our square root. You need to go 1 plus, then hit enter. And then it's the same thing. We'll have our negative, and our positive. So this is going to equal to y hat minus our prediction, and this is going to equal to our y hat plus our prediction. And again, We're going to do 3 decimal places. Negative 1.671 and positive 9.409. And there we go. Okay, it takes a little bit to get the confidence intervals, but once you get the formula in, again, it slowly builds out a little bit easier. And they didn't really change when the individual prediction x equals 4. Alright, next. We have a nice table here. Yay! So, first thing it wants to do is to perform the scatter data plot. So again, we actually have Excel do this for us. Highlight all the information. Make sure you hit enable editing first. Highlight, insert, and then here with the dots, there's our scatter. Okay. So here, you would try to match which one looks very similar. Oh, notice they switched. Notice how the numbers are a little bit different. So, in order to properly do this, cut, delete this, we'll redo it. Make sure we highlight everything. Okay. And scatter plot. Okay, they actually had it switched. We fixed it. So now we can actually look. So the only one that looks close to mine is this one right here. And you could probably put it side by side. But notice the 2 gaps right here. That's the highest. Then 4, then the way it goes. So, that would mean for me, scatter plot is right there. Check. It is correct. Now, it wants to find the coefficient of correlation between the 2 variables. We're going to have to do some testing. Nice. So, let's go ahead and do a regression on it. So, data analysis, regression. Go ahead and take that off and put the Y range. It's a little bit bigger than before. Highlight and put our X. Again, Y is dependent on X. So, from here, again, we have a lot of fun information. Then we have our R squared. Reason why we like R squared, because if I'm looking for a correlation, coefficient of correlation, it's just the square root of that. So I can go ahead and calculate that out. So if you did take the square root of R squared, we get 0.393. Okay, so again, using the technology at our hands, Next, we're going to state the decision rule for 0.05 significant level. So again, we have 25 minus 2 will make our degrees of freedom 23. Again, I can tell it's a one-tail by the greater and less than, since it already gave us to us. So, here on our book, again, we're using 0.05, one-tail, and we're going to be looking for 23. So 1.714. Okay, check. Make sure we got the right one. We did. Now we're going to compute the test statistic. Which again, we got to go find the formula. Remember, there's multiple formulas for testing t. So again, it's this formula right here. So we can quickly put that in. And again, don't we have this already? Let's see. Yeah, we have it on this sheet. All we needed was the correlation and the size. Well, we've already figured out the correlation to be 0.393, and the size is 25. We have 25 numbers, so we're looking at 2.04968. Well, again, we have our t-stat. Our t-stat's just a little bit different. This is probably rounding. Again, we can figure out, again, if you left it there, yay. If not, you all have to put it back in the formula. So it's 2.04, so 2.05. Again, if not, here you go. Notice with our rounding, still 2.05, because we have to round 2 decimal places. So again, just a little rounding issue, but you actually do have it in your regression. It does calculate it out. But since I already had the formula, just to double check, since we were rounding, okay, turn to question. So 2.05, 1.714. Is it greater? It is. So I'm going to have to reject the null. So look like there is a positive relationship. Again, check to make sure you did select 2 right multiple choice items. And then, what percentage of variation in revenue in the restaurant is accounted for by the number of rooms occupied? So for us, basically taking r squared, because basically we're looking at coefficient of determination. So, whoop, didn't make it all the way. So basically it's this r squared, but we're looking at percentage. So that means it's going to be 15%, 15.5. about 50.5%. And there we go. And that is question 7. Nice. Next, question 8. Question 8 is going to be a little bit fun for y'all. Y'all get to actually bring out 40 of these dots. Wow. So again, you could actually put the dot in. You could type in the numbers. So amount in number 1 is like 55. Because again, Y is 555. And X would be 4380. So that would have been my first dot. Fortunately, as you can see, it doesn't show all 4, so 40, we would have to bring out our Excel to see all of our numbers. Basically, that's all you gotta do is, on that one, is enter in each of our items. So again, they have it split. I hate when they do this because it ruins everything else. So we're gonna go ahead and cut. Oh, do I not have an edit? So, this, we'll cut that one. Huh. We close that out. Don't save. Let's try again. Huh. There we go. Enable editing. Huh. So there's actually something else in the line that's going. Wow. Sometimes this happens. It's just how the forming process is. So remember, when you put in these lines, since it will not let me edit that, Y is the amount spent. X is your monthly income. So make sure you do switch them as you go. Alright. So based on this relationship between monthly income and amount spent, does it increase or decrease based on your items? So after you're done, all you would do is tell this one, basically, is there a negative relationship, no relationship, or positive? So if I see it trending upwards as further we go, we have a positive. If it's trending down, it's negative. If it's just everywhere, it's a no relationship. I'm going to let y'all go ahead and figure that out. So again, we're going to determine the correlation coefficient. So again, I'm going to let Excel do this for us. Data analysis, regression. Again, we're going to put in our numbers. So the right range is actually in the right spot, but it needs to be bigger. So there's our Y. Our X is the income. Okay. We'll hit OK. And here's our regression analysis. Now remember, they're looking for correlation coefficient. We have correlation of determination. So we need to go equal square of this number. So we're looking at 0.8201, yep. Because they just had to be 4 decimal places. And again, these two, we'll leave that to yourselves. Turn to question. Can we conclude that there is a positive correlation between monthly income and the amount spent? Use the 0.05 significant level. Alright, so basically they want us to find the T statistic. Well, we need to find first off, our actual T stat. But right here, let's go, right click, is our calculation. We don't have to do the calculation, it's right there. All we got to do is find the critical value. So again, take our lovely T-chart. We know our degrees of freedom is n-2 are 38. We are using a 0.05 significant level. So the question is it one tail or two tail? It is indeed one tail because we're looking at positive correlation. We don't care about the negative. So it is one tail. So this is our right 0.05. And we gotta go find our number, which is 1.686. Okay, so that's our crit. Our actual calculation done by Excel is 8.83. So I would definitely say that is greater than 1.686. So we are going to reject the null. We can conclude that the correlation of the population is greater than 0. Again, since that was all drop-down bars, y'all could have kept doing check my work, but you need to understand how it works and using Excel since it's already calculated. R squared, this is already given to us by doing the regression. So 0.6725. Standard of error of estimate, this is also given to us. This is the one thing I like when software works for us. So here's our R squared, and then here's our standard error. So 143.7205. Again, I'm going to check on both of these at once. There they are. Alright, would you recommend using this regression equation to predict the amount spent with monthly income? This is going to be up to y'all. It's either going to be yes or no. If you're going to recommend, because it does have a good, basically a positive, it actually does predict very well. About 67% can be defined. So yeah, that works. Okay, question 9. Alright, question 9 in itself looks like a lot of information that we could just pull from regression data analysis. So we're going to do that. So let it open. Again, we're dealing with 40 numbers. And notice this. Price equals. So this actually tells me my Y is, again, price per share. And since I don't trust this item, because that's a little interesting how it came to be. We're not going to change them. We're not going to cut. We're going to do it the same way. So data analysis, regression, and since this is all already inputted. Oh, we got a function range. So let's go ahead and put it in. And then put output range right there. So delete. There we go. Okay. And again, if you could include the price of dividend, it would probably put price of dividend up here. But that's fine. All we can do is now interpret how it calculated for us. So price equals the y-intercept, which was 26.975. Again, we're going to be rounding. So remember, y-intercept, and there's our slope. So 2.4082. Check. Huh. That's new. So let's see if there's a rounding issue. Yeah, remember, we had that trouble with, what was it, chapter 12? Yeah, so we're dealing with a rounding issue. So let's see. Huh. I think something's off on mine. I'm going to try and redo this. I'm going to redo it, see if it comes out to the same, because it looks like there's an error. Okay. So we're going to do this one more time, see if we come up with the same. We're not going to change the links. Okay. Oops. No, we come out to the right one. It seems like there is a slight error. Huh, go figure. Alright, so, let's see if it's 26.9054. It is not. So there is actually an error with mine. Huh. Like I said, go figure. So this is the key. So we could either, because that is the correct answer. It just looks like somehow it did not go in correctly for their algorithmic. So let's see if I can play with the numbers. It will not come out correctly. Okay, so the big key thing here is that I know for for a fact that it's going to be 26 something. Usually all of them are randomly to 26. But what I want you to do is, if this is popping up as an error for you, take this, screenshot it to show me, and then send me your Excel. Okay? Because again, the numbers may be a little bit random. But, yeah, it's a little off. I don't know if it's because the links have changed or there's an actual error. So, yeah, so it is slightly off. And I don't know exactly where it got it from. Now, unfortunately, I cannot go pop up the answers here. So, I do know it is slightly off. It's not running exactly with us. It even says the following is information on price per share and dividends of sample of 30 companies, or it gives us 40. There is something a little fishy because it does take 30 when it downloads the Excel. So, it's a little off. This question's fun. Okay. So it is wrong. The McGraw-Hill does have an error, which happens. We find it. And so all I can do is have you let me know that yours is popping up error, but you are finding the right coefficient using the regression analysis. All right. State the null and alternative hypothesis. Okay, so this is for our beta. So there's only two possible ways. You can either do equal 0 or less than or equal to 0. Probably going to be doing equal. Oh. Usually that's the one that we typically do. There you go. Alright. So it is a two-tail. So state the decision rule with a 0.5 significant level. Why is it two-tail? Again, it's equal. So, and then it also gives you the plus minus here to let you know that's two-tail. So using our chart, 0.05 and n minus 2, 28 is 2.048. Alright. So, there's our significant level. Compute the value of the test statistic. Let's see if this is even remotely correct. Because again, it is slightly off. I want to see if I use my regression. And that's correct. So again, there's our t-stat. It is already calculated in the regression. For some reason for mine, McGraw-Hill has the wrong y-intercept. There's an error. The standard error. Standard error is being infected. So what is our decision? Well, it basically does not fall in between. It is greater than 2.048. So we're going to tell the null, goodbye. You are the weakest null. Goodbye. So we will reject it. So can we conclude the slope is not equal to 0? Yes, we can conclude it. Because again, our test was equal to 0 if we accepted the null. Since we cannot, we can conclude it does not equal to 0. Then determine the coefficient of determination. Again, RXL already did that for us. 0.6583. Check, because again, we don't know if there's another error in this because of a different error. Okay, determine the correlation coefficient. Y'all know this drill? We're going to hit equal square root of r squared equals 0.8114. Again, notice how I'm always double checking my stuff. Alright, can you conclude that it is greater than 0 using the 0.05 significant level? So they're doing another test on the correlation coefficient, which we are going to reject because we can conclude the population is greater than 0. Okay, now this one is actually a one-tail, but I mean, if we even looked up one tail with the same number, so one tail is the second column, it is lower than our two tail. So if our two tail failed and we reject, we're probably going to reject the one tail test. Alright, if the dividend is $10, what is the predicted price per share? Now this one may be also our second error, because again, our y is messed up. Now if your y is correct, it should actually work out. So if I calculate, for me, it's 10 times 2.4082 plus 26.9754. Again, basically it's your x variable, your slope, times wherever x is, it happens to be 10, plus your y-intercept. So I would end up coming out to 51.0754. Sure, I did put that in right. Nope, I transposed. So 51.0574. And I will tell you it's probably going to say wrong. It will. So again, that's because there's an error right here. So we're going to have two answers that have an error. So basically, definitely send me your information on that. Alright, next, interval. So, biggest things that I'm going to need to know is my mean. What is my x bar? And the sum of x bar. And won't let me change any part of the array on this one. So, we're going to go ahead and copy these numbers. I'm going to find my nice little chart that we've already done. These two. Which is this one. So that was question... Well, I think we just inserted those. Yeah, we just did. So we're going to go ahead, hit paste. We're going to change the number. So we're going to go formulas, auto sum, and we know we need to divide this by 30. Alright, so that's 10.68. So here, 10.68. We're going to have to fix all this. Okay, and this will equal the sum of all these numbers. Alright, so in our formula, right here, we are going to need to change the mean. Now 10.8, 10.68, sorry. And we have $10. Okay. And now D8 is no longer there. It's all the way down here. There we go. Okay, so all I did was modify the formula, because since I already had it basically calculated right here, now all we need to do is put in our information. Now, I will already tell you, this is going to be wrong for me, because this is my right hat. It's already off. But I'm going to go ahead and calculate it anyway. And we already found t-value when we were trying to do this information. But, again, be careful, because this is 95%, so different confidence interval. So, we're going to double check. Oh, 95% right there is exactly 2.048. Because that is the one at 28. Notice how it calculates. And again, I will tell you this is going pop wrong because there's the error at the beginning. But again, if you put in the information, show me everything that you put in correctly, I will give you the credit. Okay? And it will show wrong because there's an error. Can't solve the error when that's part of that formula. Okay. 10. Alright, question 10 in itself. A customer is buying corruptive testing cooperative tested I don't know why I can't say that word all of a sudden. The effective heating area of 20 different electric space heaters with different wattages. Here are the results. Yay! Compute the correlation between the wattage and heating area. Is there a direct or indirect relationship? Okay, so again, hopefully not too much change. So, do I want to see if there is a correlation? Well, there's two ways. Again, we can highlight. We know that we're going to switch these because the area is the independent wattage is dependent on the area. Because I want to do a scatter. Wow, the scatter plot actually shows basically not really a correlation going on. So let's confirm this. How do we confirm it? Let's try and put our data in. Okay. So our Y range is indeed wattage. And then our X range okay. So if I tell it to do that, notice how small even our coefficient of determination is. There's really not a big correlation going on here. So, but we can actually put it out because they want us to calculate, so might as well Excel. So correlation coefficient, again we know, take the square root of our R squared and it's a 0.0399. Again, closer to 0 than it is closer to 1. So it's a very weak one. Alright, so let's go ahead and look up the formula for correlation just to see what's going on here. It seems like, again, they're not taking my regression. Alright. So we can actually go through all this correlation coefficient, all this fun stuff. And let's see if there's an error going on. So our table, we're going to insert few. Alright, we need to find the sum formula, auto sum. Divide by 20. See if we come out to the same information that we have here. Which this will equal the same. So we're going to have the x minus x bar so x minus its x bar, which is 144.25. Do all that. And Then we do it for the y. So this equals to the y minus 1362.5. Then we're going to multiply the 2. And find the sum of this. So again, we're going to try and see if we've come up to the same number or a different number using the formula. So, formula for this, we still need the standard deviations. So, more functions, stats. Let's go find the standard deviation. Sample. Here's our range for our x. Hit OK. And then again, we're going to do the standard deviation for our y. So stats, standard deviation. Alright, so here's our two standard deviations. So, x, y. Alright, so our formula is equal to this number divided by, parentheses, 19 n minus 1. Or I can just do, just do n minus 1 times the x times the y standard. So it's a negative 0.033993. So that's the one. Did all that work and it ends up being a negative. And it still says it's wrong. Yeah. So, I do have an error. I have another error. So again, if you're popping up errors like I am, then we know that you are doing it correct if you show me the information. Because this one, I don't know if it's a rounding. So let's see if we change the method a little bit. 0.30398. No. Well, 0.0397. Nope. About 0.04. Yeah. So there is an error going on. Nice. Well, at least I'm showing the error so that y'all can see what's going on. So conduct a test of hypothesis to determine if it is reasonable that the coefficient is greater than 0. Use the 0.01 significant level. Round immediately calculations to 3 decimal places. Okay. So basically, I think this is just a t-test. So t-stat is negative 0.169. Again, I'll have to put in my calculations. Negative, oh, yeah, exit. Negative 0.16. Actually, 170. Yeah. So, I think I'm going to actually throw this question out on y'all. Because it seems like it is completely false. I mean, you will get some correct answers. But I already feel this one is a little off. Yeah, I'm going to just go ahead and throw out this question. It is, unfortunately, it is not correct in the way it works. So, sorry about that. Okay, so with the bummer of 10 just being all screwy because it couldn't properly do algorithmic, that concludes chapter 13. Let me know if you have any questions.